everyone, and welcome to lesson 5.1. Today's notes are going to come not from your Springboard book. They are going to instead come from the supplemental notes that I should have given you in class, or you can find on Google Classroom. On these notes, we see that we have a coordinate plane, and it wants us to find the distance between P and Q, aka the length of a segment. So we're going to start by graphing those 2 points. Point P, it says, is at 1, 4. So 1 to the right and up 4. Q is at 13, 9. So to the right 13 and up 9. So you want to make sure you graph these points, and then we're going to connect them. Now, it is not easy right now to calculate this distance because it's not horizontal or vertical. But what we can do is if we draw in a point that connects and creates a right triangle, we'll call this R. Now we have 2 segments that we can pretty easily count, right? Because we can count from 1 to 13, we moved a total of 12 units. And then from R up to Q, we moved a total of 5 units. So what we're doing here is we can actually draw in the horizontal and vertical pieces. So 12 units and 5 units. And now we're actually able to count those. Now, to actually find the length of what we want, P to Q, we're going to use Pythagorean theorem. So Pythagorean theorem does is it calls this hypotenuse between P and Q. It's called the hypotenuse. It would be across from our right angle. That's C. And then you can call these other 2 pieces A and B. It doesn't matter which one's A and which one's B. We're going to plug this into the formula. So we're going to plug in C squared is what we're trying to find. And A squared and B squared are 5 and 12. So when we take our calculators, we're going to take 5 squared plus 12 squared. We get 169. And notice this is C to the second power. So to undo something to the second power, what we have to do is we have to square root. So in your calculators, you will hit second button, squared. That'll get you your square root symbol, 169. We're going to hit enter. We get a distance of 13 units from P to Q. Okay. On this next one, we are given another point named J, right, which is at 4, -1. So right 4, down 1, and then K, which is left 2, up 7. So J to K, or KJ, is what we're looking for the length of. Now, side note on this one, it does not matter if when you draw in your right triangle, you go from here to here, or you could have went from here to here. What you're going to notice is the lengths are the same. So notice when you draw in your right triangle, that piece won't matter. What does matter is counting these correctly. If we're moving from 4 over here to our piece at -2, we are moving a total of 6 units. And then from this piece, this corner piece, the right angle up to K, we are moving a total of 8 units. So this time, again, we're looking for the C. So we do 8 squared plus 6 squared. So again, in your calculators, you can do 8 squared plus 6 squared. But remember, this is what C squared equals. So in order to get just C by itself, you must square root and get 10. Try number 2 on your own. You should have got on this one that when we plot our points and solve, we end up with C squared equals 2 squared plus 2 squared. So square root of 8 is going to give us a decimal, when we do eventually square root it. So you should have gotten 2.8. Now, this is a useful tactic when we have points that graph. But what if I gave you 2 points that were like 100, 100 and 98, 52? The distance between these 2 points isn't really going to be easy for us to graph necessarily, right? We'd have to create a really, really, really big graph, So that's where the distance formula is going to come into play. So the distance formula allows us to do the same exact thing that we were doing with Pythagorean theorem. It's just very useful because we don't necessarily have to graph. So how this is going to work, okay? You are going to subtract your 2x values, square it, add it to your 2y values, subtracted and squared, and then we're going to eventually square root that, okay? So let's start by setting this up. So we are going to start by setting up our value. We are going to subtract our 2x values first. So -8 minus 7, square that. We will add that to our 2y values, 5 and 3. Again, always subtraction inside here. Okay. Now, how do we type this in the calculator? Okay, 2 steps, please. Type the stuff underneath the radical first. So parentheses, -8 minus 7, close your parentheses, squared, plus 5 minus 3, close your parentheses, squared, hit enter. We get 229 is what we are taking the square root of, okay? Second step then is to actually type in 229, okay? The reason you want to do this as 2 steps is because if you try and do this with the calculators, sometimes if you don't have math print, it's not going to be pretty. Like when you try to type in square root, you might think they're giving you the first set of parentheses, but they're not. Okay, you might type this in wrong because it would take the square root. So that's why we always want to do these as 2 separate equations. This first, then you're going to square root what that answer was. So stuff under parentheses, or under the square root first, then actually take your square root, okay, to get your final distance this time of 15.1. Try number 2 on your own. All right, reminder, you should have got on this one our 2x values subtracted, 3 minus 8 squared, and then our 2y values subtracted, 8 minus 3 squared. Underneath the parentheses, we would have the square root of 50, and then when we take the square root of 50, you should have gotten about 7.1. Okay, questions on your calculator, make sure you let me know in class. Thanks, everyone.